Good morning, all of you. Last class, all important law we have start with. The inverse square law. Coulomb's inverse square law for the electrostatic force between charges. Remember, this law is applicable only for the stationary charges, and also we have told applicable for point size charges, not for extended charges. Now, what do we mean by this point charge is also a question that arises. It is an idealization. No such thing actually does exist, but it is only idealization. Why that idealization? What do we mean by point charges or extended charges? Different cases. In our next sessions, we will have a discussion about that. Now, just to recapitulate yesterday's class, this was the situation Q1, Q2. 2 point stationary charges, separation between them is R, and this is the line joining the two charges. An important thing, we will find it. Now, it can be either vacuum, the medium between the two charges, or air, or any other medium. That also plays an important role in the force between the charges. Now, Q1, Q2 symbols for the charges, R for the distance. Yesterday's inverse square law is F proportional to Q1, Q2, F proportional to 1 by R square, and this is what is F. Here one more time you just recall what is this F? Magnitude of force, which is we have told two forces here. Force on Q1 due to Q2. Force on Q2 due to Q1. Both are, here there are two vectors, two forces, both magnitudes are same, and that is what is taken here to be F 1 upon 4 pi epsilon naught permittivity of vacuum, absolute permittivity, times capital K. Remember this capital K, when do we use this capital K? Other than air or vacuum, we will use capital K. For air or vacuum, we will make this K as one direct constant we have introduced yesterday, Q1, Q2 by R square, and everything is in the scalar form. We are writing for magnitudes. 1 by 4 pi epsilon naught value is also mentioned to you. K value depends upon the medium other than air or vacuum. Right? This was our discussion. Now today let us see the same Coulombic force in the vector form. Very, very important. Now, see, I am telling you it's a very easier thing, but afterwards this is what is the basis for our most of learnings in electrostatics. As I have told you, whenever there comes an idea of vector, please do follow it 1, 2, 3 steps given by the teacher, or else afterwards it will be complete mess up with the topics or the chapter as a whole. Now let us see how to draw the vector of this Coulombic force, and afterwards let us see how do we represent it in the vector form as well. Now first thing is how to draw the vector. Now you see, one more time. Suppose this is a charge, positive charge Q1, this is charge also positive. Q1 and Q2 are 2 point charges and like charges, and this is the line joining the two charges, which is very important as I was talking about. Now like charges, the force is, see, the force between the charges always acts along the line joining the two charges. It is the English statement. Vector will be along line joining the two charges. Now you see, Q1 experiences repulsion, unlike, it is like charge, therefore it is a repulsion. Q1 experiences repulsion due to Q2, therefore, now how to draw that vector? Look here, this is the line joining the vector, line joining the two charges. Now, this is how I draw the vector. May not be visible, same blue color I am using. Look here, this is the vector I have drawn, which I call F1, 2 bar. F12 bar. Force on Q1 due to Q2. Similarly, Q2 also experiences repulsion on the line joining two charges. Line joining away. This is how we are writing the vectors now along the line joining. This is what is F21 bar. So first point is the vectors will be along the line joining the two charges. Supposing if it is the other case system of unlike charges, suppose this is plus Q1 and here comes suppose this is minus Q2, the unlike charges, system of unlike charges, then we know that it is attraction. Q1, force on Q1 is towards Q2, therefore again along the line joining F12 bar, and this is what is F21 bar. Now F12 bar and F21 bar, their action, reaction, pair, always opposite in direction. But how to draw that vector? Whether Q1 experiencing force away from Q2 or towards Q2 is an important thing, and it will be along the line joining the two charges. Hope there is no confusion, right? If we know writing this, now let us come to the point of how to have the vector form of this Coulombic force. Now, for that, earlier we have taken only the scalars, like r is the distance between the two charges and all. Now let us consider this system. Now it is having some vectors. Look at, observe it carefully. Supposing this is charge Q1, and from this origin I am writing it as a position vector R1 bar, some reference. This R1 bar is the position vector of Q1. Now here comes another charge, point charge Q2. Now this is the position vector R2 bar of Q2. Now I have told you line joining is important. So this is the line joining the two charges. Suppose it is a system of like charges, positive, positive, or both happening negative. In such case it is the repulsion. Now Q1 experiences force F12 away from Q2, repulsion I am showing. Therefore this is the vector F12 bar, and Q2, the force is what is F21 bar. Now here let us make use of our triangular laws of addition, either triangular law or parallelogram law. Now here you see, supposing if this is what is R1 bar, now I am simply reversing the direction. Simply reversing the direction. Then it will be minus R1 bar. See, this is R1 bar. Reversing direction becomes minus R1 bar. Now what is triangular law? A, B. One order I am taking. A, B, R2 bar. B, C, minus R1 bar. A, B, B, C. Answer is A, C. Therefore now this vector is what is R2 bar minus R1 bar. Now why we need this vector? See here, this R2 bar minus R1 bar vector, F21 bar is parallel to R2 bar minus R1 bar, which we call R21 bar. R21 bar. Therefore now I will write F21 bar is along R21 bar. Similarly, now it is the case that F12 bar will be a vector along R12 bar. Now we know the direction, and hence we can write the unit vector. Now remember our knowledge of vectors. A scalar form is converted into vector form by using unit vector. Remember, I didn't tell scalar is converted into vector. No, scalar form, which contains only the magnitude expression, the scalar form can be converted into vector form by using a unit vector. Therefore, now which unit vector we have to consider is discussed in this explanation. If it is, I am writing F21 bar, It is along R21 bar. Therefore now you see, I will write it in the vector form. How? If I have to write only the scalar form, I will show you. F12 bar, no bar, only magnitude if I write. F12 is equal to K times that 1 by 4 pi epsilon naught, everything is there, times Q1, Q2 upon R squared. Right? Now here, I will write it in the vector form. When vector form is done, F12 bar is K times Q1, Q2 by R square times. Just now we have mentioned that it is R12 bar. R12 bar. No, sorry, I'm sorry, R12 cap. We have to multiply this entire scalar form by this unit vector is R12 cap. And what is the definition of unit vector? We have defined it as, if A bar is a vector, A bar by magnitude of A bar is what is called as unit vector along A bar. Therefore now this R12 cap, shall I write it as R12 cap is nothing but R12 bar by R, the scalar. Therefore now F12 bar is K times, what is that K? 1 by 4 pi epsilon naught, magnitude 9 times 10 raised 9. Q1, Q2 by R squared times R12 cap definition is R12 cap definition is R12 bar by R. Right? This R square into R, we can write it as R cube. So F12 bar is K times Q1, Q2 by R cube times R12 bar. Now don't say that it has converted into inverse cubic relation. No, it is still inverse square relation only. Q term is there, but you have also another R bar term in the numerator. Therefore still it is inverse square now. Now this is for what I am writing Q1, Q2 greater than 0. So what is the meaning of Q1, Q2 greater than 0? Means both are like charges. So having same sign, when they are multiplied, you get positive value. That is what is the meaning. Q1, Q2 greater than 0 means system of like charges. Right? Like charges, this is what is the expression. Similarly, you can write F21 bar is K times Q1, Q2 by R cube times R21 bar for F21 bar. Now supposing if it is unlike charges, what do we write? Yes, the same expression, but now since it is unlike charges, the forces are just reversing. F12 bar earlier was away from Q2, whereas if it is like charges, F12 bar will be towards Q2. The vector is reversing. Therefore, I will write F12 bar is K times Q1, Q2, R cube times, this is now I will write it as R21 bar. So this is for system of unlike charges, and hence I am writing Q1, Q2 less than 0. Positive, negative multiplied, we are getting negative value less than 0. So this is for unlike charges. So this is how we write the expression. The most important thing is we get very few examples based on this vector form for forces. Most of the times, at least for our board exam, NEET exam and CET exam, maybe for JEE examination, this vector form representation and all may be good in numericals. But at least for all these other examinations, this is a very, very trivial case. But drawing the vector is a must. Because we next see when in the other session or in the same session, the drawing vectors and adding vectors is the basis for most of the examples. And that is why be very clear about drawing the vector. So this is Coulomb's law in the vector form. Now let us write all the characteristics of Coulomb's law. Again 2 marks questions, 1 mark questions, 3 marks, everything will be there. So in the following lesson, you underline each and every point, because every statement is an answer for your 1 mark question or 2 mark question. If all the characters, maybe a question can be asked for 3 marks as well. Now let us see that. It's a very important discussion, because in this discussion we will have a comparison with the already known inverse square law in our first PU. You remember in the gravitation topic we have learned about Newton's universal law of gravitation. There also we have given one inverse square law. Newton's inverse square law of gravity is there. Now there are many parallels between Newton's inverse square law and Coulomb's inverse square law. Similarities are there. At the same time, there are some differences also. So that is how we will look at all the characters, not just specific to Coulombic force, but also in comparison with other forces also we will have a discussion. The first one is Coulombic force. It forms action-reaction pair. Action-reaction pair. See, for every of the character I will give an explanation. What is the meaning of this action-reaction pair? Now it can be either 1 mark question or it can be a CET NEET question. See, suppose he says this is some charge of 5 Coulomb and this is a charge of 1 Coulomb. This is the line joining. Now he says the force on, and these are the only 2 charges, no other charges in the neighborhood. If the charge on 5 Coulomb is some F, what is the force on this 1 Coulomb? Electrostatic force we are talking. Force on 5 Coulomb is F. What is the force on 1 Coulomb? So generally students, some of the students at least, they will mislead by that charges. So if this is 5 Coulomb, more force. If it is a weaker charge, therefore small force. No, it is not like that. Why? Because we said F proportional to Q1, Q2. Therefore, if the force on 5 Coulomb is F, the force on 1 Coulomb is also F. That is one important point. That is how we understand the action-reaction pair. Equal, opposite, acting on 2 different charges. Now when it comes to the question of the range of the force, range means the maximum distance up to which this force can exert. A charge can exert this force, that is what is called as range. Now again, in comparison with gravity, gravitation force is a long range force in the nature. However large may be the distance, like a few millions of kilometers, also gravitation force exists. But it is not the case with the Coulombic force. But again, when we compare this with another force in the nature called nuclear force, then the range is much more, and that is why, strictly speaking, we can call it as a medium range force, but sometimes we can also call it as a long range force. So as I have told you, long range is actually the gravitation force, but in comparison with the nuclear force I am mentioning here, the fittest word would be medium range force. Therefore now I am writing it as it is a medium range force. Medium range force and stronger force. Medium range, stronger force I am writing. Stronger force I am writing. Again comparison. When I am using these words, it will be in the relative sense. This is a stronger force comparison to gravitational force. Gravitational force is the weakest. As compared to gravitation, it is very, very strong, many orders. Sometimes even it can be order of 10 rise, 30, 35 orders also. But when compared to nuclear forces, it is lesser in its magnitude. So generally I am writing it as a strong force. And that is why I am writing it as a stronger force I am writing in comparison with our Newton's gravitational force. It is a medium range force and also strong force. Now here comes one more very important point, 2 to 3 that I am mentioning. It is a conservative force. It is a conservative force. Now all these things are not new parameters or statements. About the force, the conservative nature and non-conservative nature we have studied in our first PU. Force is said to be conservative if the work done by or against the force is independent of path, depends only on the initial and final positions but not on the actual path that is followed, then the force is said to be conservative. Also, one more important point is that in the case of conservative force, the work done in a closed path is always zero. So this is how we learnt the conservative. If that is not the case, we will call it as non-conservative forces. One of the non-conservative forces we have discussed in our first PU is frictional force, non-conservative force. Now for conservative force, first year we have learnt gravitational force. Now here comes another conservative force, which is Coulombic force. So it is a conservative force. It is a conservative force, and also add one more thing, conservative and central force. Central force is also a definition that we have learned in our first page. A force is said to be conservative when if the work done is independent of the path, whereas central force definition, you remember we have told in the first page, if force satisfies two conditions such as force depends on distance, and number two is force always acting towards a fixed point, then with these conditions the force is said to be central force. Now here already we have seen F proportional to 1 by r square, dependence of distance. And what is the meaning of always acting towards a fixed point? Now see here, supposing if I consider two charges Q1 and Q2, and supposing this positive and negative, this is the line joining the two charges, and this is how we draw the vectors. F12 bar and F21 bar, the two vectors, and both are now acting towards this center. Right? We can take that way. Those two are always towards. Supposing if the positions changes, after a while, suppose Q1 comes to this position and Q2 comes to this position, then also what happens if this is the line joining, the forces, yes, the direction certainly changes for the forces, but we will find that nature always acting towards this particular point will be going on. So for all such cases, the force is said to be central force. So Coulombic force is a conservative force, and also it is a central force. And one more important point. Now when we said about the Coulombic force, gravitational force is also conservative, gravitational force is also central force. Now, most important point to understand with Coulomb's law is, it obeys principle of superposition. It obeys principle of superposition. This is also not a new thing, because this is discussed even with respect to gravitational force. Because again, gravitational force is also obeys the principle of superposition. Now you see what is the meaning of that. Let us give an explanation. Now, suppose this is charge Q1 and Q2. Charges Q1 and Q2, this is the line joining, suppose. The force between the charges Q1 and Q2, suppose it is some number or symbol F. Only two charges are there, and the force between Q1 and Q2 is F. Now, supposing we have made a small change in the system. Now, Q1 and Q2, supposing I am now bringing one more charge, a third charge is brought into the system and placed on the same line joining or at some other point. Supposing I have placed at this point another charge Q3, supposing. Need not be on the line joining, anywhere in their vicinity, the neighborhood, I have brought one more charge. Now, two charge has become a system of three charges. Now you see, now also force between Q1 and Q2 will be the same. Force between Q1 and Q2 is the same in the presence or absence of Q3. So the force between two charges is not affected by the presence or absence of the other charges in their neighborhood, is the principle of superposition. Now remember, I have told force between the charges is not affected. In fact, the net force on Q1 may change. Net force on Q2 may change. What does not change is force between Q1 and Q2. That is what is the principle of superposition. And actually, if it is not the case of principle of superposition in the nature, then it is impossible to find the forces that are experienced by the charges when it is multiple systems. Thank God, thanks to nature that it is providing this one. So what is principle of superposition? Two charges, the force between them is not affected by the presence or absence of other charges in there. Now let us also see one more important property or character, I don't say, one of the important concepts regarding Coulomb's law. Till now we have seen those characteristics. Now I will say the limitations of Coulombic force. Limitations. Because it is seen that Coulombic force is not applicable in all the cases. In some of the cases, we cannot use this Coulombic force. What is that? First one. Of course, in the very beginning we have told it is applicable only for static charges and point charges. Not for extended charges, it is not applicable, right? So first limitation is applicable only for yes, point and stationary charge. Now you will get a doubt. Sir, supposing if it is extended charge, then how to calculate force? Is it not? Because supposing if this is a rod and it is charged positively or negatively, and supposing there is one more rod like this with some positive charge or negative, like or unlike. Now there is a definite force between them, and how to calculate that force? We cannot use this straight equation F is equal to K Q1 Q2 by R square. That cannot be used. Of course, it will be done by another method, which is calculus method. When you come back to our colleges and when we begin with all of our JEE practices, then we will deal such examples also. So it is applicable only for point stationary charges. Moving charges, it is not applicable. Why? Again, we will come to that point in the next stages. Other units when we understand, then we come to know. The second limitation is that, see, it is a force which depends upon the distance, such that we said F proportional to 1 by R square. Such that as the charges come closer and closer, what happens? Force between them increases. Whether attractive force or repulsive force, the magnitude of the force will increase. If we are moving away, then it will decrease in the magnitude of the force. Now, if the distance between the charges is decreased such that R for distances are less than 10 rise minus 15 meter. Look at this number. They have come very close to each other. As close as, can you just estimate that closeness? 10 rise minus 15 meter. Then Coulombic forces will not exist at all. The charges will be there, but Coulombic forces and all these expressions and these characters will disappear. For distances are less than 10 rise minus 15 meter. Yes, Coulombic force ceases, means it will not exist anymore. Let me add one more thing if you want. Coulombic force ceases, in brackets I am writing Coulombic force converts into yes, nuclear force. Only take the statement, what is the nuclear force and how it is different from that. Now let us not have any such discussion. We'll come at the right time in our second PO only. So these are the two limitations also for Coulombic force. As I have mentioned, you see, each and every character can be 1 mark question, 2 marks question. Limitations of Coulombic force, another 1 mark, 2 marks question. At the same time, we have also given a comparison between gravitational force and Coulombic force, right? In that there are many similarities and few striking differences also. What are those similarities that we have observed? Earlier we have told, right? Action-reaction pair, yes, there also action-reaction pair. Conservative force and central force, yes, applicable for both. It's a common thing between them. Obeys the principle of superposition, yes, it is also a common character between the two. Now, when it comes to the question of a distinction between Coulombic force and nuclear force, again a tough 2 marks question, unexpected 2 marks question, or it can be a conceptual question in our NEET and CET. Now, let us also show that column, the tabular column I will write to show the distinction between the two forces. Now, and I'm writing the distinction. This table will show you the distinction between them. Gravitational force, and this is a Coulombic force. To begin with, the gravitational force, it is always attractive, is it not? It is always attractive, no question of repulsion. Whereas the Coulombic force, yes, we know that like charges repel, unlike charges attract. Therefore, yes, it can be both attractive as well as repulsive. Also repulsive. Right. See, one more thing important. Earlier we have mentioned this. This is weak and long range force. Weak and long range force. Whereas here it is, we can definitely say, as compared to gravitation, I am telling you, it is not with respect to the central force. It is a short range, strong force. Short range, strong force. Any distance between the object, gravitational force exists, but not the case with Coulombic force. Over very long distances, the interaction will not be observed. And look at this one more important point as a striking difference. Gravitational force between two bodies is independent of medium between the two masses, whether masses are in air or in water or any other medium, the force will be same. So gravitational force, it is independent. It is independent means does not depend. Independent of medium between the masses. Medium between masses. Now you just recollect your yesterday's class. We said the force between charges in air, in medium, we have done with F and F dash. You remember we said F dash is equal to F by K, K for dielectric constant, which is different for different media. Therefore, it depends on medium. It depends upon the medium such that it is maximum in the case of air or vacuum between the two charges. So this is how you can also be asked in 2 marks question, or it can be a very important thing for our CET NEET conceptual questions. Write this, practice it. Now more about Coulombic force. It's been already almost 40-45 minutes. We have been discussing Coulombic force for the last 1 hour, you remember. Sorry, last one and a half hours we are continuing with this concept of Coulombic force. I am doing it with good details. Still more details it requires for our JEE examinations also. But at least for present class, we are doing with more details. 1 hour, more than 1 hour it has been the case. Go through that, numbers, the characteristics, everything, practice very well after your session. Now, earlier we have seen only 2 charges, like or unlike, and the force between them. Now, a step further. What about the system of multiple charges? Multiple means more than 2, any number. 3 charges, 4, 18, so on. in such system of multiple charges, how to find the force. Now, when there is multiple charges, what do we mean by force? What do we mean by net force, the effective force? Let us see those details. Now, to begin with the multiple charges, I am taking 3 charges. Afterwards, the same rules we will apply for any number of charges in the system. Now look at this case. I have shown Q1, Q2, Q3. 3 charges all are collinear on the same straight line, or it can be like this also. They are not collinear. I call them as coplanar. So collinear charges, coplanar charges. Now, for JEE examinations, it can be a case of non-coplanar charges also. Afterwards, we will discuss good details about that. Now here, I will concentrate, or I will do only for the case of collinear charges and coplanar charges. Now you see here, 3 charges Q1, Q2, Q3. Such that Q1, Q2, the distance between them, I will take it as, suppose R1. This distance is R1 between Q1 and Q2, and between Q2 and Q3, some symbol I am giving you as some R2. Therefore, distance between Q1 and Q3 will be R1 plus R2. Now, what do we mean by force and net force here? Supposing if you consider this charge Q1, it will experience 2 forces. Force due to Q2. Again, depending upon the sign, either attractive force or repulsive force. Again, there is a force between Q1 and Q3 also. Supposing if I give you some signs, suppose this is a positive charge, this is a positive charge, and this is a negative charge. Now, the point is that on which of the charges we are finding the force? What is the charge of observation? That is to be first taken. Otherwise, we cannot do example. It will be the charge of observation. Which charge is asked? Supposing I am talking about Q1, I will do that. I will also do it for Q2, and it will be your turn to do it for Q3 as a small homework. Now you see for this Q1, suppose I take this charge Q1, and Q2 is also positive, like charges, repulsion. Therefore, what you find is one force in this direction, which is F12 bar. Force on Q1 due to Q2 towards your left hand side. Repulsion, I have told you, line joining towards or away depending upon the sign. Now Q1 also experiences force due to Q3, and now look at these signs. They are unlike positive, negative. Therefore, one more force experienced by Q1, which is attraction, that is towards Q3. Therefore, now this is another vector. I am writing it as F13 bar. So only 2 forces are there. So when you have a system of 3 charges, any one of the charge will experience 2 forces, such that drawing the vectors is the most important thing. Because force is a vector quantity, whenever we are writing net force, scalars should never be used. It is always vector addition laws. Therefore, now you can see that they are opposite in direction, anti-parallel vectors. You got this is F13 bar, Baba. This is F13 bar. F12 bar, F13 bar, opposite. What is the other possibility? That is, they can be either anti-parallel or they can be parallel. Only 2 possibilities. Q1 experiences 2 forces. They can be either parallel or anti-parallel. Similarly, the case of Q2 also experiences 2 forces. Again, it can be parallel or anti-parallel. Remember, attraction, repulsion should not be confused with parallel and anti-parallel. First, looking to the nature of the sign, draw vectors, and then you find those vectors whether parallel or anti-parallel. Now clearly F12 bar, F13 bar, anti-parallel. Therefore, now here I am writing what is net force. And of course, parallelogram law of vectors, theta is equal to 0 degrees, what happens? Theta equal to 180 degrees, what happens? Other than that, if angle is theta, for everything we use root of p squared plus q squared plus 2pq. cos theta. Opposite direction, theta is equal to 180 cos 180 minus 1, right? So similarly, for parallel vectors, theta is equal to 0, you will get cos theta is equal to 1. Therefore, F net is equal to, I am now writing F12 difference F13, I am tying minus value. Difference we get, right? For theta equal to 180. Therefore, in the case of collinear, we have only two possibilities. Either the two forces are added, whatever forces that are taken for the charge of observation, two forces, they are either added or they are subtracted from one another. Now what is the meaning of this? When do we use F1 plus F2? When they are parallel. When do we use this minus sign? When they are anti-parallel. If I am writing F1 minus F2, it means that F1 is greater than F2. Higher value minus lower value I am writing. So this is what is the net force. This is the net force. Multiple charges. To begin with, the simplest of the case. Instead of 2, we have taken 3, and also the simplest way because the collinear charges only case of F1 plus F2 or F1 minus F2. Now we will do examples tomorrow session. In that session we will also throw light on the simplification part also, which is an important thing. Now if this is what is the case of collinear, now look at this coplanar. As I have told you earlier, any system of multiple charges, what is the rule? What is the mantra? Draw vectors, add vectors. And vector addition is very experienced thing for us from our first PU. Now see here, coplanar I am showing Q1, Q2, Q3, three charges. And supposing this distance I take it as some R1, this distance what I take it as R2, and this distance I take it as some R3, scale on triangle. If all of them are same, equilateral triangle, isosceles triangle, any triangle can be given. The only thing is that we have to now find what is the charge of observation. On which charge you have to write the net force. Because earlier I have told you there are two forces experienced by each of the charge. When we take the resultant, that is what is called as the net force. Now here again, supposing I am taking net force on Q3 or Q1 or Q2. Now again here also the important thing is looking to the sign convention. Supposing let me take all of them are like their system of like charges or system of unlike charges. Drawing vectors already we know. Therefore now in this case, supposing if I am drawing the vectors on Q1 and finding the net force, since Q1 positive charge, Q2 like charge, therefore it repulsion, this is what is F12 bar. F12 bar. Of course we write the magnitude as F12 bar. Yes, magnitude I will write it as F12 is equal to yes K times 1 by 4 pi epsilon naught Q1 Q2 by R1 square. Now this is the vector. Now Q3, Q1. Q1 also experiences force due to Q3. It's again like charges. Therefore along the line joining, see this was the line joining, along the line joining I will be drawing one more vector. This vector I will call it as F13 bar. Such that what will be the magnitude F13? The magnitude is yes same K times 1 by 4 pi epsilon naught 9 into 10 by 9. Every time I am repeating that so that you don't have a confusion and it will be easy for you with simplifications. Q1, Q3, because it is between the pace Q1 and Q3 we are writing upon R3 square. Now we will find these two vectors, they are not collinear. There is some angle between them. This angle I will take it as some theta. Now I know two magnitudes and angle between them. Therefore, what will be the net force? Yes, our famous parallelogram law, and we got this parallelogram or triangle. Resultant is always given by this equation. Net force is root of F1 squared, F2 squared, that the force F12, F13, that the forces are written, right? F12 square plus F2 square plus 2 F1 F2 cos theta will give you the result. collinear, F1 plus F2 or F1 minus F2. For coplanar, we will make use of this equation, writing the individual forces. Now when it comes to our board examination, or CET, or even for that matter, NEET also, 99.9% of the times there will be a symmetry, such as we are given here a triangle which I have shown as a scale-on triangle, but in the examination they made it easy. They give you as equilateral triangle. Or if it is system of 4 charges, they will make it as a square, like that. So all such cases as numericals, let us do in our next session. Remember, almost 1.5 hours we did for Coulombic force, remember. If it were our regular classroom, other than video, if it were our interactive session, we would have made more than 2 hours. So for video class, I am reducing the length, at least 1.5 hours I did. Go through each of the details. Any of your doubts, post in the description box, comment box. Otherwise, you can feel your liberty to call me anytime. Have a good day. Have a good practice.